Well, let's move on into, I think we'll do this today. So we'll do factoring difference of squares. We'll put both of those in. Not too tough. So what is the factored form of x squared minus 9? So the factored form of x squared minus 9. So notice that there is no middle term here. So I can really rewrite this. This is z. Actually, z squared plus 0 z minus 9. So when I define my a, b, and c values, a is going to be 1, right there. Let's kind of get some highlighters going here. A is going to be 1. B is going to be equal to 0. There is no middle term. These ones are kind of the easiest ones to do once you get the hang of them. And c is going to be equal to negative 9. All right, put that one in purple here. So c is negative 9. So I can still do my x with this. So I can still factor this. What multiplies to negative 9 and adds to 0? Well, the answer is going to be 3 and negative 3. So 3 and negative 3. So they're the same, but opposites. Okay, so 3 and negative 3. So the answer is going to be, this is going to factor into x plus 3, x minus 3. Squeeze that in. Trying to avoid the right side of my iPad. In a moment of weakness, I gave it to my daughter to watch something, and then she got up and dropped it on the floor, cracked the right side of the screen. So I'm trying to stay on the left side, but this one will go over here. So x plus 3 times x minus 3, that is the factored form. So there's no middle term. So this one says rewrite it as a square, factor using the rule of difference of two squares, check your answer by multiplying the factored form. So let's kind of skip right to this step. Let's check it by using the box method. So we're doing this step right here. We kind of already did those other steps. So this is x plus 3, x minus 3, and I get x squared right there. This should be z, but we're at x squared, so that's x squared. This is negative 9 right there. And then notice I get 3x here and negative 3x here. These are going to cancel out. Okay, so there is nothing there. All right, try this got it problem number 3. What is the factored form of each expression? So again, pause the video and see what you get here. Okay, well, let's do these. So this is going to be negative 100 and 0. Well, it's got to be negative 10 and 10. Okay, so this is going to factor into v minus 10, v plus 10. Okay, kind of a shortcut you can do here is you can just take the square root of these, if you want to think of it like that, and then make one a plus, one a minus. So the square root of v squared is v, and the square root of 100 is 10. And then you just got to do plus or minus 10, kind of a little shortcut. All right, s squared minus 16. Well, the square root of 16 is 4. So if you want to take a shortcut, it's s plus 4, s minus 4. Okay, so those are the length and the width there, the dimensions. Difference of squares. So really what we're doing is, it's a difference of squares. Let me explain this. I'll shrink this down here. Why is this called the difference of squares? Well, you do have two squares. You have s squared minus 16. Okay, and then so you really have two squares because s squared is a square and 16 is a perfect square, so it looks like that. All right, let's do one where we have, what is the factored form of 16x squared minus 81? Okay, well, this is where the kind of the shortcut comes in handy. I can think about what's the square root of this and what's the square root of this. Square root of 16 is 4, and the square root of 81 is 9, so it's 4x plus 9, 4x minus 9. And you can check this with the box method. Okay, but that's kind of a little shortcut. You can try this one, pause it real quick, try that one. After you've paused it, you can see that the square root of 25 is 5, and the square root of 64 is 8, so it's 5d minus 8, 5d plus 8. And it says the expression, let's look at this other part. So reasoning, the expression 25d squared plus 64 contains two perfect squares. Can you use method in problem 4 to factor it? Well, explain your reasoning. The answer is no. There's no such thing as the sum of squares. So this is a problem here. There's no such thing as, you can't factor it. So if I were to do 25d squared plus 64 and try to factor this into 5d plus 8, 5d plus 8, that's not going to work out. So there's no such thing as sum of squares. So I could just prove this real quick using the box method. This is 5d plus 8, 5d plus 8. This is going to be 25d squared, so that works. This is going to be 64, so that works. But the problem is I have a 40d here and a 40d here, so that would be 80d. So where is the 80d? ADD. So where is that? It's not there. So that is the answer to this is no. And that's the reason, because of that middle term. All right. Factoring out a common factor first. So what is the factored form? We got 24g squared minus 6. Well, these both have a 6 in common. So I can factor out a 6 first. And I'm going to be left with 6 times the quantity of 4g minus 1. And then I can recognize that these are both perfect squares here. A 1 is a perfect square. So I can rewrite this as 6, and then the square root of 4g is 2g. Square root of 1 is 1. And since it's a minus sign here, I have a difference of squares, so that's 2g plus 1. All right, so again, I got my 2g right there. That makes 4, and then I have my difference of squares here. Okay, last problem for today. Try number 5, A and B. Okay, where you got to factor something out. All right, so I'm going to factor out a 12 here. And when I factor out a 12, I'm left with t squared minus 4. And then I can factor that again into t plus 2, t minus 2. So I have a difference of squares here. So my 4 factors into 2 and negative 2. And then my t squared is t and t right there. Okay, the next one, what can you do with part B when you factor something out? Well, you can factor out a 3 from all of these first. So you always want to look to factor out something first. So I factor out a 3, and I'm left with 4x squared plus 4x plus 1. Okay, and if you always got to try this. If I try the x method here, I know my a value is 4, and 4 times 1, a times c is going to be 4. This is 4. This is 4x. This is 4x. What multiplies to 4 and adds to 4 is going to be 2. Okay, and then I can reduce these right here. I'll squeeze it in. So this is going to be 2x plus 1. So I can write 2x plus 1 times 2x plus 1. Okay, if you're not quite getting these right here, example 5, problem 5, we're going to go into those a little bit more. All right, so do your homework, and then we'll see you again later on this week in the Zoom meeting. So we got Monday, we're doing 8-7 today. Wednesday is 8-8, and then we will review on Friday, and sometime next week we'll have an assessment on Chapter 8, and we'll turn in all